Thank you very much, Corey. I haven't been keeping up my blog as much as I'd like to. Well, a lot of teaching this particular term. I've left 52 students in one class behind with a graduate student, so I hope everything's okay when I get back. So I got a lot of writing to do. What I'd like to talk about now is the advances in pasture seed production. We're going to talk about grasses. Richard will be talking about clovers a bit later. The kinds of information that I'll be talking about, this could be Phil Launceston from Ag Research in New Zealand giving the same talk. Could be Bertha Bolt up in Denmark giving the same talk. We work together. We have common problems around the world in terms of the limitations to grass seed production. And what I'd like to illustrate right now is seed yield potential versus actual yield. When we produce a seed crop, we're really putting out about 10,000 kilograms per hectare worth of flowers. The problem is we don't convert all of those flowers to seed. We're very biologically inefficient in these grasses, and even Oregon, we've not solved this problem. So our research efforts, not only at Oregon State University, but at Ag Research, and FAR, and various other places around the world where this work is done, it's really aimed at capturing a greater portion of the seed yield potential. And that's where we're getting the yield gains. We're trying to figure out how to make more of these flowers into seed. And we'll talk about some of the ways that we're doing that in terms of our research. Richard mentioned Trinexapac-ethyl plant growth regulators. That's been a big improvement in our seed production in Oregon, as well as what we saw previously from New Zealand. Part of our job is to try to understand why things work, not just that they work, but why they work, and so how we can make them better. And if you look, in fact, in the late 90s and early 2000s, when we first started this research and had the first product registration for Modus, known as Palisade in the United States, on grass seed crops, we saw some differences. In fact, one of the things that producers told us when they looked at these trials is they said, look at this. This is a treated tiller, and this is what they had been used to looking at in perennial ryegrass. And they said, Tom, it looks like it's on steroids or something, you know, and it's all pumped up. And one of the big differences is that there's a lot more flowers per spike and many more seeds per spike. And if you compare the treated versus the untreated, there's only about 8 seeds per spike difference. And you're thinking, oh, that's not very important. But if you multiply that times 5 million spikes per hectare, that's a lot of seed. And you're increasing the number of seed per unit area. These growth regulators are supposed to be lodging control agents, but they do all kinds of other wonderful things. Even when we don't have big lodging in Oregon, we see improvements in seed yield with Trinexapac-ethyl. If you look at the numbers of seeds for both perennial ryegrass and tall fescue, we see increases as we increase the rate of Trinexapac-ethyl. I've got this in grams AI per hectare, but if 200, 400, 600, if you want to think about this as 800 milliliters or 1.6 liters or 2.4 liters per hectare, that's another way to look at it and maybe a little bit more familiar with what you're thinking about. So both perennial ryegrass and tall fescue, we see increases in the numbers of seeds produced as a result of applications of Trinexapac-ethyl. So in terms of yields in perennial ryegrass, in this and some of the following slides, you'll see that I'll have different letters behind the means. When those letters are the same, it means it's not statistically different. If they're different, there is a statistical difference. So in perennial ryegrass, we see the yields increase as we increase the rate, topping out about 400 or about 1.6 liters per hectare in terms of the rates, in terms of seed yields for perennial ryegrass. In terms of lodging control, we're getting effective lodging control across these rates, and we're also reducing the length of the stems in perennial ryegrass. If you were to look at similar work for tall fescue, we see the same sorts of results, but we don't see as big a yield response or as consistent as a yield response in tall fescue as we do in perennial ryegrass. Again, there's an increase from no Train-X-Spec ethyl up to some rate of Train-X-Spec ethyl, but there's no differences among the different rates in terms of seed yield. We also saw a reduction in lodging, and we saw an increase in stem length reduction. So the chemical is working just as advertised across all of these different rates that we looked at. In terms of the timing effects of Train-X-Spec ethyl, these are stages. So this growth stage 32 right here, that's 2 nodes, basically during stem elongation. That's typically when we like to apply it, and so the recommendations for this particular chemical were made really for this window for us between about 32 and about 50, and that's inflorescence emergence for the crop. That's for perennial ryegrass. We didn't even try tall fescue outside of that. We'd expect that it wouldn't be as effective, just like in perennial ryegrass. We see really no differences across seed yields in tall fescue in those. In terms of timing effects, we see in tall fescue that there were no differences for lodging control, and really not a big difference in terms of stem length reduction, although the inflorescence application tended to have a little less stem length reduction, and that's to be expected. Nitrogen management. You know, we looked at a number of fields yesterday, and we were talking about nutrient management in grass seed crops, and one of the things that we really want to hammer home is the fact, yeah, there's a number of nutrients, but one of them is really important and has a big effect on your seed yield, and that's nitrogen. Basically, for us, spring nitrogen is the most important time for application under our environment, under organ conditions. And the daily nitrogen use for both perennial ryegrass and tall fescue peaks during this early stem elongation period, basically before about ABCH 30. So what we recommend for our producers under our particular set of circumstances is for best nitrogen use efficiency that nitrogen application should precede stem elongation. Now there's a little bit of difference in terms of that nitrogen uptake, and here's a recent graphic that we just produced, Nicole Anderson, John Hart, and myself. It's part of a publication on tall fescue and perennial ryegrass, and you can see our seasonal nitrogen use here. For tall fescue, basically the crop is going to take up all of that, all of the nitrogen that it's ever going to need, essentially by the time the inflorescence or the panicle comes out in that tall fescue. Perennial ryegrass, it's starting to slow down about that point. It can take up a little bit more nitrogen, so you can have some little bit later nitrogen applications, but those are not going to be quite as effective as some of the earlier applications in terms of seed yield for the crop. Just to look at an example for perennial ryegrass, basically you can see that over a 12-year period, we had these results across these nitrogen rates, and yes, there were some producers once upon a time that were putting on 300 kilograms of spring nitrogen per hectare. It was basically wasting money. Because as you can see that there's quite a nice curvilinear relationship to yields. We backed off the growers way across that, back over to about 180. That's about where the industry's at right now in spring nitrogen application. Certainly we saw an increase in the number of spike, certainly as a result of nitrogen applications, but seed weight was also a big portion of that. And we can see that seed weight increases compared to no nitrogen by quite a bit. So it's not just seed number, but in some instances, seed weight also is increased as a result of certain management practices, and they can have an effect on the yield of the crop. There's also an interaction between plant growth regulators and nitrogen. This has been well established in a couple of different crops, perennial ryegrass and tall fescue in Oregon. My colleagues in New Zealand have found the same sort of results in these crops. Basically, the PGR really doesn't do anything on its own without nitrogen. Nitrogen is really the thing that drives it. What does nitrogen do in the plant? The perennial ryegrass that you see behind us on this picture is really a biological solar energy collector. You put the nitrogen on, increases the leaf area, you capture that solar energy is fixed using atmospheric carbon from the atmosphere and carbohydrates, right? So we're filling that seed, literally that weight of that seed and the numbers of seeds, we're filling each of those with starch. And that's really basically what seed production is all about. The genetics, of course, is in the embryo. But you got to have food for that seed. And that's really what we're doing with this nitrogen. So we increase seed yield with the nitrogen, with no PGR. And we can see in each of those years that we got a further increase in yield. So we built this bigger biological solar energy collector, and we're able to capture more of that solar energy using the PGR. And really what it's doing for us, it's increasing the numbers of seeds. And we see this right here. Seed number is really highly related to seed yield. So nitrogen plus PGR is up at the upper end. So you put those together, you got a winning combination. In terms of irrigation, I know there's a lot of concern and questions about irrigation. We don't, in the drier parts of the state, irrigation is essential because we only have 150 to 200 millimeters of rainfall per year. But in the 1,000 millimeter per rainfall part of the Willamette Valley, it's not been a big deal for us in the past. But that's changing. We're seeing more and more irrigation, later cultivars that have later maturity into the drier parts of the year, and particularly in the springtime. And so if you look at this chart right here, we can see again the rainfall like I told you earlier about, and here is the growing degree days, and so this is essentially crop growth. So in the fall, we don't see a lot of need for irrigation. In fact, we see no significant increases in seed yield as a result of fall irrigation in perennial ryegrass or tall fescue seed crops. But in the springtime, we see the growth going one way, the amount of rainfall going the other direction. Well, that's very good for the drying and management of that crop in the field. We don't have to use artificial dryers. We just cut it in windrows, let the solar power dry it down, and we come back a few days later or a couple weeks later, depending on the weather conditions, and pick it up with a combine and thresh it all out. It's all great. In fact, when we have too much seed, we can even stack it in big piles outside the seed cleaning sheds and concrete pads. You can't do that if it's raining outside. And so that's good for us. But think about our crops, though, particularly on more well-drained soils. There might be a need for irrigation. In fact, we've done some research on that, and spring irrigation is indeed beneficial. And with this increased amount of irrigation in the valley, about 114,000 hectares at this point, we can see some certain benefits for both perennial ryegrass and tall fescue seed crops. And so growers have changed their mind about irrigation in these crops, and they're starting to do more in the springtime where it's available. If you look at the timing of irrigation in terms of seasonally, within a season as well as seasonally, we see from stem elongation, flowering, and drying of the soil, as to be expected. That parallels the reduction in water during the springtime that we saw from the previous slide. But there's different ways that you could manage the water. You could keep the water on, as many producers have, over the entire period. Basically, we would call that a multiple irrigation, where you do multiple sets and not let the too big of a water deficit take place. Or you could do a single application of water strategically about flowering, or just prior to flowering, to fill the soil profile just in time to support seed filling of the crop. In a crop like perennial ryegrass, we actually saw an increase from the multiple irrigation, a slight increase over what we saw with just a single irrigation. But in tall fescue, all you needed was one strategic timing of water, and that was it. The multiple irrigation didn't improve seed yield over just one shot of water. What about cultivars? Do they all respond the same way? Well, in tall fescue, at least the ones that we tested, they'll respond pretty much the same way. In perennial ryegrass, on the other hand, we saw differences. And this is a regression chart that I prepared. On this, we have environmental means, so it's really dry on this end, and then irrigated a lot more on this end, so we saw this environmental means, this higher and higher yield due to more and more water. So most of the cultivars increase in terms of their yields across this gradient of increasing water. But check out this cultivar, Derby Supreme. It didn't matter. It didn't want to be irrigated. It doesn't care. You can put all the water you want on it. So that's something you have to know about your crops too as well. Is the water going to make a difference for you? In terms of spring irrigation, again, just like what we talked about for nitrogen and the PTR interactions, seed yield increases as a result of seed numbers. This is from some work that we published a year back on tall fescue in irrigation. Now, remember we started out with 10,000 kilograms per hectare seed. We lost all the way to 2,000. Well, that's over like a 30-day period. And a lot of that is due to abortion of the seeds. And we think that a lot what irrigation does is it reduces that seed abortion losses, and so increasing the number of seeds harvested from the crop. The other problem that we have is stand age. Our farmers see that they plant a seed crop and the yields decline over the age of the stand. Perennial ryegrass and tall fescue both. This is pretty well established. We're working on some papers to look at this and to do more research on that, but we take quite a big yield hit. 500 kgs per hectare in that first year. You can do like our friends do in New Zealand, just not plant a second year. That's one way to avoid it. But our growers have the tradition of doing multiple years, and the typical stand life is about 3 years right now for perennial ryegrass in the Napa Valley. That's what they have contracts for. But they're taking a yield hit compared to that first year. Why are the yields different? Well, one of the things that we see is there's fewer flowers. For some reason, the crop actually flowers less as it ages. The other thing that seems to be going on, and we see, in addition to the reduction in flowering, we see a reduction in numbers of seeds. We looked at carbohydrate content and stem bases and other kinds of characteristics. We don't see a lot of differences there. One question that came up was roots. Do the roots change over time? And we followed. In fact, if you could imagine, if this was a plant right here, so this is the center of the row, and then going out 30 centimeters, so this is a 30 centimeter row spacing, this particular crop, we can see that the roots develop over time, and this is the depth in the profile down to 30 centimeters deep. Roots don't get very deep on perennial ryegrass, so we didn't have to dig very deep. We watched all of these roots, and we see that the darker colors are higher levels of root biomass. And certainly we can see that there's changes over time, but there's no reductions really. In fact, the biomass increases in the stand age, so the loss in the seed yield, the loss in the vigor of that stand really isn't related to any reduction in the root system over time of that crop. So what are our challenges? The one big one that we've taken on, basically at Methven last year in New Zealand, researchers around the world talked about one thing that we could really work on together, and that is seed shattering. Crops lose seed no matter what you do. In perennial ryegrass, the shattering can cause 10 to 20% losses, maybe more. Some of the New Zealand research suggests that maybe as high as 50% of the losses. We've done a lot of work to try to solve this. We've put on glues, we've tried to plant growth regulators. None of that's really worked very well. We've adopted harvest timing based on seed moisture content. That helps if you follow those guidelines, get out there. But even if you do everything right, you still lose seed yield. Even the best growers lose seed yield. And so one of the things that we're starting to work on between ourselves and New Zealand and other places is cooperative trials to try to figure out how to control seed shattering, and we hope that Tasmania will be a part of that in the future too as well. That's what I have in terms of research and development and grass seed production, and I'll turn it over to Richard to talk about the similar sorts of things in our forage lighting seed crops. Thank you.